Absorption and reflection of sound. At the end of this session, you will be able to describe reflection and absorption as two important properties of sound with day-to-day experiences. You know that just like light, the sound is energy that travels as a wave through a medium like air. A sound wave can travel as long as it has energy, and when the energy finishes, it dies out in the air. But what happens to these sound waves when they hit any surface on their way? Is this what makes us to hear an echo effect? Do they get absorbed on the way? Let's explore. Reflection and absorption of sound. If you throw water forcefully through a thick spongy cloth, only some water would pass through the cloth. Some water drop would be absorbed by the cloth. Some water drops would bounce back to you. The similar thing happens with the sound waves. Just like the water hits the cloth surface, the sound waves hit the surfaces in their way. On hitting a surface, some sound waves pass through the surface or get transmitted. Some of the sound waves are absorbed by the surface itself, and some of the sound waves come back to the source. When a sound wave hits a surface and travels back to the source, it is called as reflection of sound. Reflection and absorption of the sound waves are important properties of sound that we experience in our day-to-day life. The echo effect. Hello, hello. Have you ever tried producing a sound like this? If you shout loudly in front of a tall building or a hill, you can hear back the words you said as if the building or the hill has repeated it. We call this repeated sound as echo. Echo is a sound wave that hits a surface and gets reflected back towards the source. But when a building is surrounded by many trees, houses, hoardings, we do not hear any echo. One reason for this absorption of some of the sound waves by soft surfaces. Even if the sound is reflected by hard surfaces, the occurrence of the echo effect depends upon the time and distance factors. After hearing the first sound, if the second sound wave is reflected back from such a short distance that it reaches our ear before 0.1 second, then our ears cannot recognize it as a separate sound. Hence, the echo effect cannot be experienced. The time lag of 0.1 second, that is 1/10th part of a second, is required between the source wave and the reflected wave to experience an echo. If we send sound from such a distance that sound wave cannot return before 0.1 second, then the echo can be heard. In 1 second, sound travels 340 meters. In 0.1 second, sound can travel 34 meters. So, removing barriers and shouting from at least 34 meters away from the building will make the sound waves to come back after time lag of 0.1 second, producing the echo effect. In an empty room, the sound waves hit the walls and get reflected. This creates echo if sufficient distance and time exists. As there are no barriers in room, the energy of the waves lasts for longer and they do not die out even when the next sound waves are produced. Several such sound waves overlap, making us to hear unusual and unclear sound. But when the room is furnished, soft curtains, porous foam and flat wooden surfaces absorb the sound waves, preventing the reflection and echo effect. The soft surfaces like cloth and foam absorb the sound waves, but the hard surfaces like walls reflect the sound waves. And the sound waves which are reflected travel a very short distance and reach ears before 0.1 second. This saves us from hearing the repetition of each sound produced in the room. However, big halls such as a cinema hall or auditorium have larger walls with sufficient distance, causing repetition of sound. Covering the walls with soft and porous sound absorbing material kills the echo and gives best sound clarity. As human body is a good sound absorber, a houseful hall also helps for sound absorption. Uses of sound reflection. Echo effect and sound reflection has many uses. Animals like bats and dolphins send the sound waves, and the reflected sound waves help them to sense the location and size of their prey, such as insects or fish. The echo effect helps the marine professionals to locate the objects such as the school of fish or a submarine weapon or even precious treasures. The sound waves sent under the sea are reflected back, helping the device to reveal the distance, direction, and the position of the target. This application of sound reflection is called as sonar effect. Thus, we learned about the important properties of sound, that is sound reflection and sound absorption.
Hi dear students, welcome back to the class. Today we are going to discussing the topic echoes. The last video we have discussed about reflection of sound and absorption of sound. I hope all of you understood that topic. Okay. You must have visited an echo point at all the hill. If you shout loudly at such a point, you hear the same sound just after a little while. If in time you hear like this, yes, this sound is called an echo. What? Echo. An echo is the repetition of the original sound because of reflection by some surface. That is called what? Echo. In order to be able to hear the original sound and its reflection distinctly, at 22 degrees Celsius, what must the minimum distance be between the source and the reflecting surface? What is the reflecting surface? At 22 degrees Celsius, the velocity of sound in air is 344 meter per second. 344 meter per second. Okay. Our brain retains a sound 2.1 second. Thus, for us to be able to hear a distinct echo, the sound should take more than 0.1 second after starting from the source to get reflected and come back to us. Clear? Yeah. See how the sound that come back to us. Yes, it will take how many times? 0.1 second. Thus, we can determine the minimum distance between the source and the reflecting surface as follows. Like that. Okay. So, distance equal to speed into multiply time. Substitute the values. What's the values? Yes, that's equal to speed equal to 344 meter per second into time, that is how much? 0.1 second. So how can you calculate? Yes, multiply it, you will get the answer 34.4 meter. So thus, to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the above, that is 17.2 meter. Is it clear? So the reflecting surface from the receiver and the transmitter from the distance is how much? Yes, that is 17.2 meter. At the velocity of the sound depends on the temperature of air. This distance depends. So now we are going to discussing the topic sonar. So what is sonar? What is the full form of sonar? Sound navigation and ringing. Okay. So sonar is a technique that uses sound propagation to navigate, communicate with or detect objects on or under the surface of the water, such as other vessels. There are two types of sonar, that is passive and active sonar. So what is this passive sonar? Sonar is essentially listening for the sound made by vessels. Okay, and active sonar is emitting pulses of sound and listening echoes. The acoustic frequencies used in sonar system vary from low to extremely high. So this low sound means that is infrasonic sound, and the extremely high one, that is ultrasonic sound. You know, this ultrasonic sound we are cannot able to perceive. That is good for our health. Otherwise, it affect our brain. Okay, okay. And in case of bat, you know, this bat use that ultrasonic sound. So brain got the bat got the brain hemorrhage? No. Why? Because bat can produce vibrations in the frequencies range of 500 hertz, 50 hertz to 80,000 hertz. That's why. Okay. And next is, what is sonar? Is device fitted in the ship to find the depth of sea is called sonar. It is based on the principle of reflection of sound. From the point A, ultrasonic vibrations are sent. These vibrations are striking the seabed, get reflected upward, and are picked up at point B. The time in which reflected sound is received is recorded. So, knowing the speed of sound in water, 1500 meter per second, and the time taken for the reflected sound to reach the sonar, the depth can be calculated. So, how can we calculate? Let's calculate. Okay, the speed of the sound in water, that is equal to distance covered by sound upon time. So 1500 meter per second equal to distance covered by sound upon 1.2 second. Therefore, distance covered by sound equal to 1500 multiply 1.2 equal to how much? Equal to 1800 meter. Therefore, the depth of sea equal to how much? Yes, 1800 meter. Okay, thank you. Hi dear students, welcome back to the class. I hope all are you fine? Yes, okay. So the last video we are discussed about, yes, echoes and sonar. Yeah. So today we are going to discussing another topic. See, did you hear the different variety of sound produced in different bodies? Yes. Your sound and your mother's sounds same? No. And a crow and the cuckoo, the same sound? No. And flute and drum, it's producing the same sound? No. So, in our life, we hear different kinds of sound. Okay, just think about your friend and your sound. It's same? No, it's a different. This different sound. So we hear a wide variety of a sound producing in a different vibrating bodies. Okay. different object producing different sound, because either they have different loudness or pitch. Okay, so what is this loudness? So the sound, that is depends upon what? The loudness and pitch. Okay, so first one is loudness or intensity of sound. What? Loudness or intensity of sound. Okay, so what is this loudness? Which distinguishes a favorable sound from a loud sound of the same frequency. This is what loudness. Okay, the loudness of the sound that depends upon the amplitude of the vibrating body. The loudness of the sound that is depends upon the amplitude of the vibrating body. Is it clear? That is, more amplitude, more loudness, more sound. So less amplitude, very less sound, that is less loudness. Okay, so the loudness is the characteristic of distinguishes favorable sound from a loud sound of the same frequency. Okay, so this loudness or intensity of sound that depends upon the amplitude of the vibrating body. So high amplitude means what? Large sound, otherwise more loudness. Okay, and less amplitude means what? Very less loudness or very less sound. Clear? And what are the properties of loudness? Yes, the property of loudness, the loudness that depends on the area of the vibrating body. Area of the vibrating body. Okay, just take two drums. One is big one and small one. Okay, and the small area, when you are hit on the drum, it will produce, a big drum, it will produce what? High sound. That means loudness, because of the amplitude is small. Okay, and the small drum, when you hit on the small drum, it will produce very less sound, because the amplitude of the vibrating body, that is very producing very less sound, very less amplitude, very less sound. So this amplitude of the sound wave is directly related to the energy it carries. We can say that what more energy is carried sound wave. Loudness that depend upon the area of the vibrating body. And the second property, the loudness that depends upon the length of the source of sound. This loudness decreases with the increase in distance from the source of sound. Okay, so the loudness depends upon the area of the surface means, yes, the large area producing what? More vibrations. Air vibrations, there are more vibrations. Okay, so it producing large sound, and the small area producing very less sound. An example, yes, in case of pool and the bucket of water. Okay, when you throw the stone to the pool or into the pool, it will producing more sound. Yes, it producing more vibrations. You can show that vibrations, the ring comes into the pool. In same case, just throw that same stone into the bucket of water, it producing more sound? No, very less sound, because of what? The area of the vibrating body, that is very small in case of bucket of water, and in case of pool, the area of the body, that is more. Okay, and the second one what? Yes, it's decreases with the increase of distance of a source of sound. Yeah. Sometimes you heard that anywhere in the marriage you can hear the sound clearly. They are using what? The speakers, because of the large, more distance. But we can hear that what? The sound very slowly, very less sound we can able to hear. But in case of you are just standing in front of that speaker, you can hear the sound very slowly. No, it's a too much sound. the loudness. You can hear the more sound. Okay. Sometimes when you are sitting in the class, those who are sitting in the last bench, you told what, ma'am, I can't able to hear your voice. Why? Because of the distance from the source of sound. Those who are sitting in the front, they can hear. So, these are the examples of what the source distance from the source of sound. Okay. And the next is pitch. This you heard this pitch, high pitch, low pitch. What is this pitch? You know that the boys and women, their voice are same? No. You know the woman's sound, or this voice. Woman's voice is more shrill than man's voice. Flute sound is more shrill than drum sound. So a shrill sound is called what? High pitch. And the soft sound, soft or less shrill, that is called what? Low pitch. So what is this pitch? Shrill is the effect produced in the ear, that is due to the sound of particular frequency. What is pitch? The effect produced in the ear due to which some particular frequencies, that is called as what? Pitch. That is called as what? Pitch. Okay. So what is this high pitch and low pitch? High pitch means the pitch that depends upon the frequency of vibrations body. The pitch that depends upon the frequency of vibrating body. In case of loudness, that depends upon the what? Amplitude of vibrating body. Okay, amplitude of vibrating body. In case of loudness, in case of pitch, what? Yes, that depends upon the frequency of vibrating body. Okay, yes. And the next one, the more frequency, that is what? High pitch. Okay, less frequency, that is what? Low pitch. So what is this high frequency? High pitch or shrill, it producing the vibrating body, it's a high frequency. Okay, and low pitch means what? It's producing the frequency very less frequency. It's producing the sound, it's a very less frequency, that is what? Low pitch. Okay. So in your textbook there is given 4 activities. You have to read that. Okay. So once again, you know that in our surroundings we can hear different varieties of sound. Okay, that depends on loudness or pitch. Okay, so what is loudness? Loudness is the characteristics of sound which distinguishes the feeble sound from loud sound of the same frequency, and this depends on the amplitude of the vibrating body. What are the properties? Yes, the loudness that depends upon the area of the vibrating body. Okay, large area, high loudness, or small loudness, and a small area, very less loudness. Okay, and the second one, yes, that decreases with the increase in the distance of from the source of what? Sound. Okay, very far. The source of sound very far, we can hear very less sound, and the source of sound is very near, so we can hear more sound. Okay, so these are the 2 property, and next is pitch, and you know that the pitch, that is what the effect that produced here due to the sound of some particular frequencies. Okay, this is depends upon the frequencies. The pitch depends upon the frequency of the vibrating body. High frequency, that is high pitch or shrill. Okay, and the low frequency, that is what? Bass or flat. Yeah. I hope all of you understood this topic. Yes, thank you.
Timbre.
Another word for timbre is tone or quality of sound. Timbre is the distinguishing characteristics that differentiate one sound from another despite the fact that they might be playing the same frequency with the same amplitude. When we are describing a sound timbre, we use words like sharp, loud, reedy, brassy, or bright to describe them. Let's correlate timber to flavor. Think of apples. They are a type of fruit that has a typical shape, color, and flavor. But inside the category of apples, there is a huge amount of variations. Some apples are very sweet, while others are more sour. Some are red while others are green. They are all still apples, but each one with a distinct characteristics. Red delicious is different from each other. Even when describing one type, there are might be variations from apples to apple. Same thing goes for sound source. One category of timbre we use quite often is string. Inside of the string family, we have violin, viola, cellos, and double basses. They have similar timbres and tones in same ways, but each one is distinct when comparing two different violins. One might have a very bright sound, while the other is more muted and dark. Even when playing one violin, we have produced a different timbres by bowing it different ways. So, what is timbre or quality of sound? Yeah, that is due to which two notes of same pitch and loudness produced by two different vibrating bodies can be distinguished is called what? Quality of sound or timbre. Okay. Even in the human beings, vocal cords are of the same length and same thickness. Yet the speech of two persons does not resemble. It is because the sound produced is modified depending upon the shape of mouth cavity, shape of teeth, the way the tongue is moved, the shape of lips, etc. And the next topic is monotone. When someone speaks in a monotone, his voice is flat and boring and everything sounds the same. A continuous sound, especially monotone voice that does not rise and fall in pitch, is a monotone. So, what is the definition? A sound of single frequency is called a monotone. So, it's describe how monotone is a sound which is repeated on one note without change of pitch, while a pure note is a sound of one peculiar frequency. This is what monotone. And next we are going to discussing about the unit of loudness in decibel. The loudness of sound is measured in decibel, dB. It signifies the sound pressure level. So what is decibel? A decibel is unit of comparing the loudness of two different sound. It is not a unit of absolute measurement. The usual basis of comparison is a barely audible sound, the sound of a very quiet room, or 0.0002 Pascal, at which 0 decibel is set. And bells and decibels. The unit used to compare the loudness of sound was originally the bell. In the commemoration of the word of Alexander Graham Bell, which was the logarithm of the intensity ratios 10 raised to 1. This unit was considered too large to be useful. So a unit one-tenth the size of a bell, the decibel, was adopted. In your textbook, there is given the source of sound and loudness level and effects of sound on human ear. Please read that. Okay, thank you. Sound as longitudinal wave. We have seen how sound propagates through a medium. When the object vibrates, it creates the disturbance in the surrounding medium, and this disturbance is what we call as sound waves. The waves travel in the medium in the form of compressions and rarefactions, but in which direction do the particles of the medium vibrate? Before we answer that question, we will talk about longitudinal waves. What are longitudinal waves? Let me tell you. The fancy definition: first, waves in which the particles of the medium vibrate in the direction parallel or anti-parallel to the direction of energy transport are called longitudinal waves. That mean before we get to the statement, do you remember what parallel and anti-parallel means? Parallel would be two vectors like this and anti-parallel will be two vectors like this parallel button. Opposite directions. Now coming back to statement, it means that if the rays travel in this direction, then the particles of the medium also moved to and fro along this direction. Only so the displacement of particles is parallel or anti-parallel of the direction of the propagation of wave is sound wave. A longitudinal wave, take these examples and try to find out. Yes, sound waves are interior longitudinal waves. We see this in this example, but that the particles of the medium vibrating in the direction of propagation of wave, sound waves are parallel wave. Can you tell me why it is repeating patterns of high pressure regions? High pressure regions called compressions and low pressure regions called rarefactions. Therefore, the medium but weight hold on are the waves in which displacement of particles of the medium is not in the direction of the wave. The answer is yes. Let's see one example in which the propagation of the particles is perpendicular to the direction of propagation of the wave. Take a string with one and fix it to the wall. And this end is fixed at the wall here, and this one is in your hand. Okay, another one is your hand, and we see a wave when we give the string an upward jerk from this end. What do you notice here? In what direction are the particles of the string moving? Up and down, right? And what about the directions of the propagation of the wave? It's moving to the right. Let me repeat at once. The particles in the string are moving up and down, while the direction of propagation of the wave is towards the right. Particles are vibrating in a direction perpendicular to the direction of the wave. Such waves are called what? Transverse waves. So, are sound waves transverse waves? The answer no. And it's because the particles of the medium are vibrating in the direction of propagation of wave here. What is longitudinal wave? When the particles of a medium oscillate in the same direction in which the wave is being propagated, then the wave so formed is called what? Longitudinal wave. Okay, the sound wave produced in air are an example of longitudinal wave. Next, we are going to discussing vibrations are the cause of sound. Let's watch this.
Wrap a rubber band around an empty shoebox. Listen, listen, you hear nothing. Strike the rubber band with your finger quickly. Listen, listen, you hear something. Now the rubber band's in motion, and that motion is vibration. You can hear the sound of that vibration carried by the air. Vibration, vibration, vibration is what causes sound. Vibration, vibration, vibration causes sound. Now Tony and his guitar will show you how to control the pitch of a sound by changing the vibration. He raises the pitch by tightening the string. And he lowers the pitch by loosening the string. He raises the pitch by shortening the string with his fingers. He lowers the pitch by lengthening the string with his fingers. He raises the pitch by using a light string. Oh, pretty. And he lowers the pitch by using a heavy string. Boys and girls, you've just heard a scientific demonstration which proves that the pitch of a sound is changed by changing the vibration. Vibration, vibration, vibration is what causes sound. Vibration, vibration, vibration causes sound. Vibration, vibration, vibration is what causes sound. Vibration, vibration, vibration causes sound.
So we know about what every source of sound is a vibrating body. So let us see one experiment. What it is proved, sound is produced due to vibration produced in a medium. Let's watch this experiment. So this experiment proves what? Sound is produced due to vibrations produced in a medium. Okay, thank you. Source of sound. Here we are taking tuning fork, that is U-shaped fork of steel. Provided with a steel handle, the two arms of U are called prongs and V is the handle, that is called stem. So let's start the experiment. Just watch this video.
Fork. Here we take air as a medium of propagation. Here we have a tuning fork made up of steel. This shows the initial condition of the air particles of the medium when the tuning fork is in its original position, that is, when tuning fork is not vibrating. When we strike its prong on a rubber band, we start hearing a sound. How does the sound travel through the medium? The two prongs of tuning fork are vibrating. Let us concentrate on motion of one of the prongs first. Say the one on the right. When it's away from its mean position, it pushes and compresses the air particles around it. This creates a high pressure region, also called compression. This compression travels in the medium as a disturbance. Here the density is high. That is, the particles are very close to each other. When the prong comes towards its mean position, the pressure on the right decreases and keeps on decreasing further as the prong continues its motion towards left. This creates a low pressure region, also called as rarefaction. We see that at this point, the compression in the form of disturbance has reached this region. This rarefaction also travels in the medium as a disturbance. Here the density of particles is less. That is, the particles are far away from each other. As it continues to vibrate, we get a series of these compressions and rarefactions. This continuous sequence of compressions and rarefactions is what we call sound waves. Yes, the sound waves travel in the form of compressions and rarefactions. Instead of the tuning fork, if we take any other source of sound, say the speaker, then the sound waves generated by this object will also travel in the form of compressions and rarefactions. Here is one interesting question. Is the sound wave a mechanical wave? Do you know what a mechanical wave is? The mechanical wave is a wave that requires some material medium to travel. And as we know, a sound wave also requires some medium to travel. So yes, it is a mechanical wave.
I hope all of you understood that experiment. Okay. Next, we are going to discussing the human beings. In case of human beings, so we human beings produce sound when our vocal cords vibrate on blowing air through them by our lungs. Actually, sound is produced by the larynx or voice box. The two vocal cords are the ligaments which are stretched across the voice box. The voice box has a narrow slit between the vocal cords for air to pass. Vocal cords vibrate and produce sound when air passes through the slits. Now we are going to discussing this about musical instruments. There are mainly 4 types of musical instruments. First, we are going to discussing wind instruments: flute, clarinet, cornet, shennai, and trumpet are some of the examples of wind instruments. In these instruments, the sound is produced by the vibrations of an enclosed column of air. Okay, and the next one is reed instrument. Instruments, that is their mouth organs, clarion and harmonium are some of the examples of reed instrument. They have thin strips of metals known as reeds. When the air is blown through the instrument, the reeds vibrate and produce sound. Okay, and the next instrument, that is string instrument. Next we are going to discussing that string instrument. So this string instrument, that is guitar, violin, sitar, sarod, piano and mandolin are some of the examples of stringed instruments. They have strings stretched on them. They produce sound by vibrations of stretched strings. The stretched strings are set into vibrations either by plucking them or by drawing a bow across them. Okay, this is the stringed instruments. And next is percussion instruments. What is this percussion instruments? Yes, these are drum, tabla, dholak and timpani are some of the examples of percussion instruments. In these instruments, the leather membrane is made to vibrate by striking it with a hand or a hammer so as to produce sound. So it is clear that there must be a vibrating body to produce sound. So how do the vibrations produced by a vibrating body reach our ear? Anybody knows? Okay, when a body vibrates, it transfers its energy to the molecules of air. When a body vibrates, it transfers its energy to the molecules of air or any other gas surrounding it. The molecules of air, on receiving this energy, start vibrating exactly in the same way as the given body is vibrating. When these vibrations reach our ear, they make the eardrum vibrate. When these vibrations reach our ear, they make the eardrum vibrate. Okay. So, the vibrations produced in the eardrum are carried to the brain. See? And hence we hear the sound. If you notice carefully between the vibrating body and the ear, air is a sort of medium through which the sound vibrations travel. So,
Music
sound
right
not
now.
only travels through air or gases, but also
Well, you
travels
might know
through
that your
solid and
speakers are
liquids.
creating
In
sound
fact, sound
and your
travel much
ears are
better
listening
in
to it.
solids
But
and at
there's
a
a
very high
lot
speed
more
as
going on
compared
over
to
here.
liquid and gases.
You see,
In
all
case
your
of
speakers are
solid
doing right now
solid
is
liquids,
vibrating the particles of the air close to them.
liquid sound
Then
travel
they
much
vibrate the
better
air molecules
than
close to
in
them,
gases
and
and
so
at
on
a
and so
higher
forth.
speed. So some
And we
investigations
call
are
this
given
a
in your
sound
textbook.
wave.
Okay? Two
And
investigations are given in
eventually,
your
when the air
textbook.
molecules close to your
Kindly
ears
read
start
it.
vibrating, we hear sound.
And see the
But
state of medium and the substances and the speed of sound it's passing through the substances. These are also given in your textbook. So just see that solid, that means the aluminium, brass, iron, glass, steel, nickel, these are the solids. Aluminium, the speed of sound travel in 6420 meter per second, and brass 4700 meter per second. So like this, solids, liquids and gases are given. So kindly read and learn that. Okay, thank you.